today I'm going to speak about BT's journey into GitOps and how it made us much better at DevOps. And just to remove any ambiguity around what DevOps means, I am considering DevOps to be the culture around developing and operating what you are delivering, rather than say maybe just pipeline work or infrastructure development. So I'm Ryan Neal, and I'm a tribe engineering lead at British Telecom. And more specifically, my tribe is called Shared Journey Capabilities. And what we do is we build capabilities as product enablers. So the sort of rough structure for how BT is structuring its teams is we have several teams working on many products, from selling mobiles to selling broadband, etc. Underpinning how those teams are delivering forms a number of different platforms that teams can use to help deliver their systems. So these platforms we consider are essentially internal products, and the customers are the product teams who have to develop. The main reason for this is we want the product teams to be focused on delivering the business value, meeting our business objectives, and the platform teams take away some level of complexity or admin from those teams, so that they can focus truly at the problems at hand. We want to reduce the conversations that product owners have to have with engineers, where they say, like, oh, we can't progress because the pipeline's broken. That could be that can be the platform's problem in this case. So it's worthwhile noting that every team in BT is absolutely customer obsessed. So the platform teams are obsessed about their customers, which are also their colleagues. So the aim of every single platform team is to try and reduce cost in terms of delivery, increase the speed of which we can deliver, and improve the quality of what we are delivering. So we're trying to meet that triangle by improving, listening to what the teams are working on, what things we can help to unblock them. So we do this by a number of means. We abstract out complexity so that teams don't have to deal with as much infrastructural problems or pipeline problems. We aim to centralize repeating patterns. So if we see a microservice pattern for communicating to a database, we try and centralize that so that people can leverage those patterns and move faster. We encourage inner sourcing. So we have several projects that are inner sourced and welcome contribution from absolutely any developer in the organization. We try to use best-in-class tech, and yes, Ryan defined best-in-class. We don't just use bleeding edge for the sake, but we definitely try. We have to keep our eyes open for new technology that can help us accelerate in terms of our platform ambitions. And of course, the most important thing of all is listen to our customers. We solicit feedback from our customers so that so that we can take that on board to the platform and make the platforms better for everyone. Today, I'm going to talk about a particular team within the tribe, which essentially is a backend platform, and the backend platform is for the ability to deliver microservices into our architecture. So their overall ambition was to provide a resilient platform with agility, which meets the customer needs. And the customer needs in this is we have product teams that need to operate as cross-functionally as DevOps. They need to develop. They need to do the microservices, get them deployed, and make sure that they're working as they expect. So the overarching architecture for what this looks like, just to put it in really simple terms, is we have the team provides some CI/CD pipelines. Then they provide a Kubernetes platform with a series of different capabilities on it, including things like monitoring, so that the teams know how their services are operating. And we provide a service mesh for the networking and other cross-functional aspects, ability to manage secrets, some security monitoring on that cluster, the actual microservice hosting themselves, and some other tools that cover other cross-functional concerns that you might encounter whilst running a Kubernetes environment. This was initially done by constructing everything in Terraform. And from this point on, I'm going to sound like I am bashing Terraform, and I sort of am. But I recognize that sometimes it can be for necessary, dependent on the type of environment that you're in. But this where our story begins is our use of Terraform and how it wasn't working for us. So we had a number of obstacles that provided a challenge for us. The AWS accounts that we host our infrastructure on is shared by other areas in the organization, and this could solicit outside changes. So it could be that there was some sort of support activity happening that would override an infrastructural change, which would then conflict with our Terraform and create delays. The change audit for our Terraform wasn't as strong as we would like. We just deploy it at one time, and then the state can change if somebody goes into AWS and modifies something, which we didn't like. We needed the ability to deploy, customize, and Helm, and Terraform support at the time was quite limited. We could install manifests and Helm charts, but we couldn't necessarily destroy safely. It was a really big problem for us. We had a really big challenge around making sure we were managing secrets correctly, that we weren't just committing secrets into Git. We did struggle to find the right level of Terraform expertise because we were trying to leverage a lot of bleeding edge tech, and those nuances create a fairly high degree of expertise. And of course, when we have to run a Terraform job and maybe it's got to deploy a number of pieces of infrastructure, we'll get extremely slow feedback loops. So, a developer might have to wait an hour or so before they could understand if their development branch is going to operate correctly or not. So from these problems, we had some requirements that could lead us towards a solution. And these were essentially a reliable approach to change. We want to be able to make sure that when we change something, that change is done safely, but also that it is always, that change is always in place. We wanted clear traceability of those. So that relating back to that change audit, we want to know who changed what when, and then the ability to change and iterate rapidly. So reducing those slow feedback loops and making sure and having a way that we can work in a much more agile manner. We want to see those changes happen much quicker. So introducing GitOps, we thought that GitOps would solve all our problems. And if I just explain for those who might not know how GitOps works. So we essentially commit our deployment definitions into Git. So if you need a Helm chart that deploys Prometheus, you define that into Git. We have controllers installed on the Kubernetes clusters. Those Kubernetes clusters are polling your Git repository for changes. Once it sees those changes occur, it will try and apply that change onto the cluster. This is really great and powerful because the Git repository becomes your single source of truth for what is deployed. You can know what's deployed in your cluster by looking at your Git repository. And then the changes, by using Git, this means that our changes are automatically audited. So this was really great, and this overcame some of the challenges here around those Helm and customize deployment problems I described earlier. But of course, we still have some reliance on Terraform because we still need to deploy the clusters that can then run the GitOps controllers. So how did we use GitOps? We opted to use Flux as a technology for this, and more specifically, we're using Flux 2. And we use this exclusively for deploying our Helm and customized deployments. So how our general code structure works is we have an environment repository for each environment. So, your non-prods, your productions. And then Flux provides us with a really great capability to reference other GitOps repositories as part of your repository. So in our case, we have a core repository with a set of default tools that we install in every cluster. Those are referenced by tags in our environment repository, so we can safely release a core version when we need to, whilst it's still being audited. And then those full changes for that environment are deployed onto Kubernetes. Obviously, between these environments, there are other changes that are occurring. Some environments only have specific tools on or specific capabilities or different microservices. So that's still managed as part of the environment repository. On the right is just an example of a Flux Helm release. So I'm going to use this as a segue to walk into a short demo. but we can see that we're defining the ability to deploy a Helm release, and we can provide some values into that. So I guess without further ado, I'll jump into the demo, and hopefully the demo gods will be shining upon us today. So I've got an environment pre-set up. We can see there's no Alfie upstream because we've not configured it to be deployed correctly yet. So as a quick walkthrough for what this GitOps repository looks like, we have a customization. We've defined a number of files that we want to deploy as part of this. We've got a couple of files here for using our Istio service mesh for exposure, which is how I'm going to be able to access it for this demo. We're installing a namespace as a standard Kubernetes manifest. We've established a repository which refers to Bitnami's repository. I'll be using Bitnami today to use as a demo repository. The release that we're going to deploy is going to be a very simple Nginx server. So we can name it whatever we want. We're applying it to the same namespace as everything else. We're referring to the Helm repository, which in this case is in the same namespace. You could opt to have a namespace that has your own Helm repositories if you wanted. We're saying we want to deploy the Nginx chart and we want to deploy this version of it. There's some other configuration around how Flux can handle this. So how long it can take to poll it, how long the Helm install timeout is. The values for the Helm chart would be the same as any values YAML that you might use for deploying with Helm. We can just apply it into this YAML instead. So, and I mentioned secrets earlier, and I'm not demonstrating this today, but you can reference secrets to merge values as well, which is how you can get secrets how you can avoid committing secrets into your GitOps repository. For this demo, we're just going to have a static site loaded from a config map that we've called static site. That static site is defined in our repository, and we're going to define the number of replica counts. So for the sake of moving on with this demo quickly then, so I'm just going to change the replica count to 1, so we actually get a deployment. We're going to go hello devlab from a file called demo.html, which is fine. Maybe for the sake of illustrating that this is working, we can load hello devlab with the header 1 in the HTML. So a very simple file just for the sake of demonstration. So we'll add this as our audited change. So I'm just going to say update for demo. We'll push this change up. And now this is where we pray to the demo gods to smile upon us today. So we're just waiting for that to push. So now that's pushed up, our Kubernetes cluster should be polling according to the configuration here every 30 seconds. What we can do is we can go to the namespace, which will already be created, which is DevLab21. We can see for the time being that it's already picked up the change. So now it's specified that the desired replicas is 1. And if we go to our pods, we can see that the Nginx is already running, which is a great result. And refreshing now, we can see that this change. So there's a very short and simple demo of using GitOps, and more specifically Flux. By leveraging this this type of technique in GitOps and the reliable change, we saw the velocity increase. Essentially, it doubled roughly, and our cycle times for delivering work was reduced by about 4 times. And more than anything, the teams were a lot happier using this and having to manage it with Terraform. So an absolute great result all around. It meant that we delivered a lot of features and functionality and could trial changes and technologies really rapidly and quickly. And even still today, we can install tooling in a really fast and flexible way for our product teams. So that's great. You've solved the problem around Helm and Customize, but we still haven't quite solved the Terraform problem. So I did identify that Terraform was a really big challenge for us. and Flux didn't solve the ability for us to install infrastructure. So we actually looked to adopt Crossplane, which is another GitOps framework, and Crossplane took the GitOps concepts that's the same as what Flux uses, but applied it to deploying infrastructure as well. And I do say not exclusively, because Crossplane has a lot of extensions that I'll get into in a short while. It's enabled us to rapidly deploy and iterate and change on how we do other types of capabilities, more notably how we deploy infrastructure onto other AWSs. So this works by we install a Crossplane provider, which acts as that GitOps controller. We have an infrastructure repository where we are applying Crossplane definitions. Crossplane takes those, applies them to the relative AWS accounts, so we could quickly install things. And as an example here, I've said, we can deploy an S3 bucket and EKS, and it's taking those configurations from this infrastructure repository. So a really rapid, quick way for us to start installing infrastructure as well, whilst getting that fast feedback that we crave. Similar to Flux, these changes are continuously synced, which means that we fix the outside changes issues that we've previously seen. If somebody goes and changes the S3 buckets configuration, the GitOps control, the Crossplane controller will change it straight back for us, which is great. We can't have those. We want those changes to be audited and clear and visible. And you're probably saying at this point, Ryan, isn't there a bit of a chicken egg scenario here? Don't you need to install infrastructure first before you can install Crossplane? And the answer is yes, unfortunately. So how our journey's worked is we've initially installed the Kubernetes cluster with Terraform because we had the framework available. We've got that up and stable. We've installed Crossplane and then migrated over our ability to manage it. So Crossplane is sort of like also managing itself, which can present potentially downstream challenges that we've not yet seen or addressed. Crossplane's provider model is extensible, so it also welcomes outside contribution. So we're starting to see providers now which accommodate for things that aren't infrastructure. Like I saw the other day, there was a GitLab one for managing things like your projects, which I thought was incredible. But there is also a Terraform provider, which means that we can install we can still deal with Terraform in the areas where Crossplane is not feature complete, as a way to get around still adopting the same GitOps frameworks and patterns. So I think as an example, Elasticsearch isn't in Crossplane today, or maybe it is, and somebody can correct me. But we still deploy Elasticsearch via Terraform, but we do that by the Crossplane extension. So why does this make us better at DevOps? We have that feedback loop where we can rapidly iterate over our deployments and technology choices and approaches. So we're getting that much faster feedback in terms of the DevOps loop. We've gained that clear visibility over what's deployed as infrastructure and what tools at all times. So we've got that clear operations view as part of how we develop this stuff. We've got clear traceability to when those changes occurred and what they were. We've provided autonomy for contribution, so it's really quick and easy for teams to contribute towards the GitOps repositories and create their desired capabilities, or at least for the platform teams to help support teams in that autonomous journey. It's a lot easier now for teams that don't necessarily have a lot of infrastructure expertise because they're focused on the business problem to establish tools or infrastructure that they require as part of their architectures. And the most important thing for me is that we've blurred lines between what is development and what is operations, because everything is still managed by that Git commit and developing out those YAML configurations, which in my eyes is perfect for enabling that DevOps culture. We've truly blended those lines between what development and operations is. So yeah, that's why I had to talk about today. Thank you for your time. I think we can probably open up for some questions.
We can indeed. Ryan. There are so many questions on GitOps. It is unbelievable.
Oh, no. This is what I was dreading.
I'm going to dive straight in just because there are so many. I'm going to just pinpoint the first one, first of all, which is why adopt GitOps in your cloud native environment, in cloud native development?
I think it comes back to sort of like we didn't adapt GitOps because we were in a cloud environment. We adopted GitOps because we were striving for a specific type of culture. That sort of like where we meld that DevOps type culture into how teams are operating and how we could actually rapidly develop. And in our case, it solved that need. So, but I would say GitOps isn't just for the cloud. I think GitOps is for any situation where maybe you're managing a Kubernetes cluster, or you've got, especially with the introduction of crossplane. I think there's probably a bit of a target on Flux's back, unfortunately, but that that enables you to do things beyond just cloud management. So
yeah. Okay. Somebody has said, does GitOps make operations redundant? Is another question.
That's a very political one. But my thoughts. I'm a really big advocate around having general specialists rather than. We enable a cross-functional culture where people just we have engineers and they get involved in any part of the faction of getting that system live. I don't particularly endorse specialisms. So so for us, I would say in a way yes, because GitOps simplifies the cognitive load required to do some of these activities. But it's not to say that depending on your organization, there'll always be a place where you need support engineers or some level of specialists in some areas. But it definitely helps reduce some of that need as an organization for it.
Yeah. There are a couple more on GitOps, but just as you mentioned, the kind of way things are structured. Somebody has said, what is the engineering team structure at BT, as it is such a big company? So I don't know whether you have some insight into how things are structured and kind of where you fit into that.
Yeah, and I'll be honest, my diagram's a little fictitious on purpose. Sorry to disappoint you. It's sort of truth. It is sort of truthful. We have platform teams, and some platforms are built on top of other platforms. So you saw in that diagram, there's like a data event team that is built on top of the backend platform. They're building data-related solutions on top of that Kubernetes platform. So some really great sort of like collaboration that happens within my tribe. BT is really large and vast. It's split up into different areas. I work for the area of the business which we call consumer digital, which was essentially formed out of the acquisition of EE by BT. So this is really only talking about how our area of the business works, not necessarily how the entirety of BT works. Yeah, of course. And I guess it's so vast. You're not going to know what's going on in every single team. But in a lot of ways, that was a really good driver for why we established platform teams, so we could centralize knowledge and capabilities in the way that we deliver things, which was really important for then how we can scale more rapidly.
Yeah, definitely. Just as we do have a few minutes, there are some more questions on GitOps. I think it is an interesting subject for people. So somebody has asked, can you break down the key principles of GitOps? I guess in a short summary for someone.
I can't say academically what they are. You're probably better off maybe going to like Flux's documentation. But for me, it's the key principles of GitOps is that you've got your source of truth is in your Git repository. There's a standard for how you define your source of truth. So through CRDs or the standard definitions that reside within Kubernetes, and that you make sure you, like the same with any type of development, that you've got a good Git strategy and how you develop and roll out those changes.
Okay. We've got oh my gosh, the questions are firing through. So
that's fine. Keep them coming.
I'll keep them coming. Yeah, of course. So we've had another question. How do you manage backups? Do you use different service providers across different regions? And how do you manage this with GitOps?
So that's a really good question. It's been actually one of the largest challenges that that backend platform team has faced, is how we establish these things. And again, it sort of like forms a little bit out of the chicken and egg scenario, like I described before. We use GitOps to deploy disaster recovery technology into the clusters, which I guess would form under that other bubble that I described. So then more specifically technologies that we use are things like Valero for the cluster backups. In terms of the infrastructural backups, we've got strategy as to how how we can recover based off that. Crossplane was actually a really great enabler for how we accomplished that. So if we lose everything on our AWS account, we've still got the Git backed up somewhere that we can then run a crossplane on to deploy it, like within minutes. So
somebody did ask, are you pure AWS cloud? And if so, have you taken a look into AWS CDK instead of Terraform? Somebody did ask also, are you really opposed to Terraform as well?
I've used Terraform. I definitely prefer crossplane. just my personal preference now. I think crossplane is a much better solution than Terraform. Well, for servicing the needs that we have, I can't claim that for the entire industry, of course. But I forgot what the first half of the question is.
The first half, you know what? Yeah, I'm immersed. Are you pure AWS cloud? And have you taken into AWS CDK?
We use a collection of clouds. This particular platform is built on AWS.
Okay, great. And then this is another fairly long question, but I think it's again an interesting one. So it sounds like somebody's struggling with options. And they've said, is there a roadmap to progressively build DevOps capabilities, particularly within small teams that are more into data analytics and machine learning?
I haven't seen anything, but some of our data people have engaged with the backend platform team about how they can enable those sorts of things. I guess in the circumstance where you want to rapidly be deploying tooling or your changes, GitOps could be a really effective model. Especially with crossplane, even if you're not using Kubernetes deployments, you've got serverless type deployments or whatever, that could really open up a door for you.
Okay, fab. There's one more as well. Somebody said, a question for Ryan. Have you always worked in DevOps?
I started off my career working on tanks and fighter jets.
Big change.
But a little bit of a change there. But I started off my career, essentially you were a systems engineer and you got involved with anything the business required, be that something software related or something electronics related. And I've always taken that mentality with me throughout my career now. So I'm into engineering whatever the business needs, and making sure our patterns and practices adopt to that. So